Alright, hey, welcome to another edition of Kung Fu Physics. We are working our way through physics GRE problems, the practice exams. I have a problem for you today. It's going to be number 41 off of this is the 92 exam. Number 41, and this is part of a combination problem. The first that I've actually recorded. And there are many of these combination problems on the GRE where they take a diagram or a description or something and they use that for a couple of the problems. But the way I've got it broken up, I still just want to do one problem at a time. That way when people are searching on YouTube, they can actually, if they know exactly how to do one part of the problem and they just need the other part, they can search for that. So I'm going to list this one as 41, and then after I'm done here, I'll make a new video as 42 is the next one we'll do. So let's go ahead and do it. It's a really easy mechanics problem. 41, and so there's this description here. Now you guys that have looked at some of these videos know that I like to scan the answers first, and in this case of a big combination problem, I mean, I could almost scan all the answers at once quickly to see if I for sure wanted to do the problem. In this case, I would certainly hope I would do this problem because it's easy. So a quick scan of the answers there shows I'm picking some value of energy, and it says the kinetic energy, so reading the problem is quick. 41, the kinetic energy lost by the cylinder is. So I guess another thing to be said about these combination problems is they actually are rather fast, because you get two for the price of one. You have to read this chunk of text up top, but you get that for both of them. So I guess my advice for people taking the physics GRE is if you are going to attempt one of these problems, you should probably do them both, because you've already invested the time to read this chunk of text. So do them both. So we're going to start with 41. The kinetic energy lost by the cylinder is. Now, we don't know anything before we read the top chunk of text. And the description it's describing is a cylinder with moment of inertia 4 kilogram meter squared about a fixed axis initially rotates at 80 radians per second about this axis. A constant torque is applied to slow it down to 40 radians per second. So real briefly, we have this cylinder that's rotating, and in our initial and final situation, the only thing that's different, I'm just going to pick a direction here, is the omega, right? In the final situation, they say initially they say omega is going at 80 rads per second, and in the final omega is slowed down to 40 rads per second. So the first thing it asks is just what is the kinetic energy lost by the cylinder. And kinetic energy, rotational kinetic energy, is really easy to calculate. It's just like a kinetic energy in translational motion, 1/2 mv squared. And you know this. You know that you can do this as far as energy of something that is rotating. Instead of m, you're using the moment of inertia, and instead of v, you're using the rotational velocity, omega. So these energies are really easy to get, and I'm blabbering on about this problem, but we could have had it solved by now. The initial energy, so I'm going to write E initial is 1/2 I, which in this case is 4, right? So 1/2 times 4 times omega squared, which is 80 squared. Okay, so I'll write that, 80 squared. And then my energy final, it's going to be 1/2 times 4 times 40 squared. Right? Now, any difference in kinetic energy has to have been caused by a force that's acting on there. But we don't need to realize that. It just says the kinetic energy lost. So whatever the difference is between these two is going to be our answer. So that's kind of a pain in the neck to calculate it, but really it's not bad. You know, you get 2 times 80 squared, which is 6,400. and then I want to subtract this, which is 2 times 40 squared, which is 1600. I should write delta E is what I want there, right? So delta E equals 2 times 6400 minus 2 times 1600. Piece of cake. Piece of cake. If you're good at doing math in your head, especially. If you got to write it out, it's going to cost you an extra step, and best if you can get away with doing as much of it as you can. And of course, I say that. As I say that, my brain freezes up. What is that? 4800. And that is 9600. I think. Is it one of our answers? It is. Whew. Answer D, 9600 joules. I'm sorry, I can't even keep that straight there. But that's how you do it. So it's just the difference of the two kinetic energies. And I took forever to describe that, but you could do that one really fast, I think. Just be careful when you do it. But that is one of the easier mechanics problems. And so I'm going to stop this video and post this one. And then shortly I'm going to post the second part, number 42. It'll be pretty short as well. So thanks, and see you on problem 42 probably.